If you struggle with a slow digestive system, you've probably been told to simply drink more water. But you can chug glass after glass, and that blockage often remains stubborn and immovable. To see why hydration alone fails, we have to look at how our digestion actually operates. The human colon functions like a highly regulated canal network, where solid waste is the cargo that needs to be transported. That cargo cannot move through this network based on the volume of water you drink. For anything to glide, the physical walls of the canal need a slippery physical barrier to prevent friction. This mucin barrier lines your intestines, acting like a biological sponge. It catches drinking water and swells into a slick, shielding gel. When cargo passes, it glides smoothly over this layer, preventing waste from scraping the delicate tissue underneath. Without this slippery coating to trap the moisture, the water you drink simply washes past. The canal remains dry, and the cargo stays stuck. The health of that lubricating gel is controlled by a microscopic workforce living right on the canal walls, your resident bacteria. One group of these bacteria is responsible for recycling old mucus. Under normal conditions, they can't consume the entire barrier because the gel is protected by a series of molecular locks. The problem begins when a second group of bacteria moves in. This second group provides a specialized biological tool that changes the environment for everyone. That tool is a specialized enzyme. It functions as a chemical release, snapping the protective locks off the mucin and exposing the fragile gel network underneath. Once those protective locks are gone, the first group of bacteria begins consuming the underlying structure, dissolving the gel and leaving the canal wall bare. Because the moisture-trapping gel is gone, the canal wall turns rigid and rough. As solid cargo tries to pass, it scrapes against the bare tissue, creating micro-cracks along the surface. These damaged, leaky walls allow microscopic toxins to move through the cracks and into the surrounding tissue, which triggers irritation and swelling. This accidental teamwork between bacteria sabotages the canal structure, turning a slippery pathway into a dry, swollen trap. A slippery surface is a great start, but a canal also needs a way to push the cargo along. That pushing force relies on a different maintenance crew. These are helpful bacteria that spend their time consuming the fiber from the food you eat. As these bacteria digest fiber, they produce small energy molecules. These molecules act as the primary power source and communication signals for the entire digestive tract. These molecules lock into sensors on the canal wall, sending an electrical pulse through the gut's internal wiring, a hidden network of nerves embedded right in the tissue. When this wiring receives those signals, it commands the muscles in the canal wall to squeeze and release in a coordinated wave, physically pushing the cargo forward. When these helpful bacteria are missing, the process breaks down. The energy molecules vanish, the internal wiring goes silent, and the muscle waves stop moving. Without these fiber-eating microbes, the gut's internal power grid is effectively unplugged, causing all movement to stagnate. To fix the stalled canal, we have to deliver a new bacterial maintenance crew to rebuild the lubrication and restart the engines. But first, they have to survive the stomach's corrosive acid. Scientists have developed a solution by encasing these bacteria inside a protective mineral shell. This submarine clears the hazards of the upper digestive tract, arriving safely at the damaged lower canal. The shell then dissolves, releasing the live bacteria directly onto the surface to work. Standard probiotics often fail because the bacteria don't survive the journey. Restoring the system requires this kind of precision delivery. Once deployed, this new crew stops the destructive bacteria from breaking down your defenses. With the environment stabilized, the lubricating gel begins to rebuild. This biological sponge returns, trapping water to create a slick coating over the canal walls. At the same time, the new bacteria begin producing energy molecules, which reboot the internal wiring and signal the muscles to move again. The pushing engines restart. The cargo meets a slick, lubricated surface, and a rhythmic muscle wave drives it forward without resistance. Real relief for a slow digestive system comes from rebuilding the hidden microbial workforce that powers and lubricates the canal from the inside out.